This week we're going to focus on bioenergetics, which is essentially how we're able to create energy and release energy from other materials. The topics and outcomes for this lecture are shown here. Now we'll focus on substrates, or things we can turn into energy, and enzymes today. Now this figure is in your book and shows how the main substrates or fuel sources can be used in the body. Notice that very little protein is used for metabolism, but also notice how these different substrates can be converted into the other substrates. And so what I mean by that is that we can actually take proteins and create glucose, okay? And we can take glucose and create fat, all right? And this is important, and we'll get into that a little bit later. So let's start by focusing off on carbohydrates or sugars. The most commonly used sugar in the body is glucose, which is a molecule made up of 6 carbons. Now, most glucose in the body is stored as glycogen, which are just chains of these glucose molecules, and then these chains are ultimately stored in the liver, or most of them are stored in the liver, and there's some stored in muscle. Now, we're able to convert 1 gram of carbohydrates into 4 kilocalories of energy. Okay, and a kilocalorie is actually what we normally refer to as a single calorie. Okay, when in fact it's actually 1,000 calories. Fun fact in case you didn't know. All right, now there are many different types of fats. Now when it comes to metabolism, the body primarily uses triglycerides, which is a single glycerol molecule that has 3 fatty acids attached to it. Now most fats are stored in adipose tissue, but there's a little bit stored in muscle. Now we're able to get much more energy out of fat than we are from carbohydrates. We get about 9 kilocalories of energy from 1 gram of fat. Then there are proteins, which are made up of amino acids, which are just compounds that have a lot of nitrogen and carbon. Proteins are generally made of several amino acids, but it might surprise you to know that very little protein is used for energy. In fact, if we're going to use protein as an energy source, then it needs to be converted into glucose via a process called gluconeogenesis, or fats, through a process called lipogenesis. The energy yield of protein is similar to that of carbohydrates in that we get about 4 kilocalories of energy per gram of protein. Now, when it comes to energy production, it's much more efficient to have this occur at a controlled rate. We just don't want to constantly be releasing a large amount of energy. In times of low energy, we want to release low levels. In times of high energy need, we want to release high levels. The rate of energy release is determined by how much substrate or fuel we have available and the activity level of the enzymes that are needed to process this fuel. So in order to produce energy, you need to have the material. If you have a lot of substrate, such as fats or carbs, you're going to be able to create more energy through these pathways, such as glycolysis or beta oxidation. Enzymes help because they allow chemical reactions to occur at a faster rate. In essence, they lower the amount of energy needed for a reaction to occur. Okay, just think of here, we've got this activation energy, and just think of this as a wall we've got to get over in order to allow the reaction to occur. An enzyme lowers the height of that wall. Now, while enzymes are helpful, they can be affected by temperature and pH. If you look at this temperature, you can see that we've got temperature on the x, or if you look at this figure, you can see that we have temperature on the x-axis and then enzyme activity on the y-axis. Okay, and you can see that peak enzyme activity is around 40 degrees Celsius. However, as we increase or decrease away from 40 degrees Celsius, enzyme activity slows down, and so it's more difficult for enzymes to do their thing. Similarly, typical body pH is in the sweet spot for enzyme activity. Normally we're at about 7.4. As pH moves away from typical values, enzyme activity slows down. And this is because pH, or acidity, affects the chemical structure of enzymes and all the other proteins that are in your body. So, exercise affects both temperature and pH, which affect enzyme activity. Exercise increases temperature, which increases enzyme activity. This is initially helpful because exercise requires more energy. And so if you need more energy, you want to be able to convert your substrate or use your substrate to create this energy. However, if core temperature gets extremely high, so above 41 degrees Celsius, then enzyme activity begins to decrease because those enzymes start to break. Similarly, exercise causes pH to decrease, or we become more acidic. This ultimately decreases enzyme activity because that increased acidity will break down the proteins which make up enzymes. It is also important to know that most physiological processes are composed of several steps. Whoops, I went wrong way. Okay, each of these steps is facilitated by an enzyme. However, in each process, there's usually an enzyme that is more important than the others, and this is what we call the rate-limiting enzyme. The activity of this rate-limiting enzyme is controlled by negative feedback loops, and we're going to discuss specific examples of this later on. But we're going to end there, and so to help review, see if you can answer these questions. Are you able to identify the three main substrates and describe what make the composition of each of these substrates? Are you able to identify the two main factors that determine energy production? And can you explain how heat and pH affect enzyme activity?